Hello everyone. So welcome you all in today's session. So we will continue same chapter permutations and combinations, and today we will discuss all the questions related to exercise 6.3, right? So be ready with your pen and notebook, and here is your first question of exercise 6.3, right? So what is given? How many three-digit numbers can be formed by using the digits 1 to 9 if no digit is repeated, right? So this question is what? If you read questions related to exercise 6.1, so this is just a recapitulation of 6.1, right? So we will solve this question by both ways, right? So here we will use permutation formula, right? We had already discussed formula for permutation is, I'm writing the formula, it is NPR, and this is equal to n factorial divided by n minus r factorial, right? And the most important part, this formula is incomplete, right? The most important part is what? R and n. What is the relation? R will be what? R can be equal to 0, right? It cannot be negative, and it is not greater than n. It can be equal to n, right? So now how many three-digit numbers can be formed by using digits 1 to 9? So here, let us solve by previous method. So we have three places. This is the unit digit, this is the tens place, and this is the hundreds place. So how we had solved this question? So first of all, we had checked whether there is any zero involved in given digits. So all nine digits are non-zero, right? So that was the first restriction. Now second is no digit is repeated, means repetition is not allowed, right? So how we will solve this question? By previous method. First of all, yes, it is not zero involved. So what we will do, we can start from either from this side or this one. So what will be the answer? This place, hundreds place, can be filled by 9 ways. So 9 into 8 into 7, that same principle of multiplication. So your answer will be 9 into 8 into 7. And by using this method, so we are having 9 digits, right? And we want three-digit number. So we will use what? Three digits out of three. And digit is not repeated. So what will be the answer? 9p3. So 9p3 means n factorial 9 factorial and 9 minus 3 whole factorial. So this will be what? 9 factorial divided by 6 factorial. And we had solved in exercise 6.2. What we will do? We will open this 9 factorial till 6 factorial, right? And look at this one. Both ways you are getting what? 9 into 8 into 7. So what is the final answer? Yes, it is 504. Both ways you will get the same answer, right? So let us move to question number 2. So here, how many four-digit numbers are there with no digit repeated? Right? How many four-digit numbers with no digit repeated? So guys, you have to be very, very careful. They have not given any set of digits, right? Like we have to make four-digit numbers from 1, 2, 3, 4, 5. So here we will use all the numbers from 0 to 9. So here one number 0 is what? It is 0, and 1 to 9, they are non-zero numbers, right? So we have to be very, very careful. Let us solve this question by using that first method. Or together, I will tell you how we apply that NPR formula, right? So first one if we talk about 4 digits number, so these are the 4 places, and here we have to be very, very careful because unit digit is this one, tens digit, hundreds digit, and this is the thousand digit. So thousand digit, first restriction is what? Thousand digit can never be zero, right? So here, out of these non-zero 9 numbers, we can choose any number, right? Or this thousand place can be filled by 9 different ways, right? So now no digit is repeated. So now we are left with what? Only 8 digit. 8 digits are left because one we have already used. So 8 non-zero digits and 1 0. So together we are having now 9 digits. So this hundreds place can be filled by 9 ways, and this will be 8 ways, and this will be 7 ways. So answer will be according to our that method we were using in exercise 6.1. So 9 into 9 into 8 into 7 is the answer, right? And if we use the formula, so look at this one. First of all, we will deal with restriction. So restriction is thousand place can never be zero. So we are having 9 non-zero numbers and we need only 1. So it will be done by 9p 1 ways, right? And remaining 3, yes, so they will be filled by 9p 3 ways, right? So 9p1 will be what? 9 factorial divided by 9 minus 1, 8 factorial. So directly I'm writing this one 9 into, so 9p3 will be what? 9 into 8 into 7. So look at this one, 9 into 9 into 8 into 7, and same you are getting here, right? So what is the final answer? I'm writing the final answer. It is 4536. So both ways you will get the same answer, right? So guys, you know these types of questions, like we can solve this question by using formula or even by basic understanding. You can solve the question, right? So let us discuss another question. Question number 3. Here we have to find how many 3-digit even numbers can be made using this one. Same, just like we were solving questions in exercise 6.1, and no digit is repeated, right? So how many 3-digit even numbers? Yes. How we were solving these questions in exercise 6.1. So these are the 3 places, right? And they are talking about even numbers. So out of these 6 numbers, how many even numbers are? 2, 4, and 6. Because a number will be even if its unit digit will be even, right? So in place of this unit digit, we can choose any number 2, 4, 6. So here we are having 3 options, right? And now out of these 3, okay, I'm writing odd also. Don't get confused. So 1, 3, and 7, right? So if we have used any of this 2, 4, 6, one number at unit place, so we are left with 2 even numbers and 3 odd numbers, right? So total we are having 5 digits, right? So at this place, we will have 5 options, and here we are having 4 because digits are non-repeated. So answer will be 60, right? And if we solve this question by using what? Method. So unit digit. So unit digit will be what? Yes, unit digit will be out of these 3 even numbers. So this will be what? This will be 3p1. And these 2 places. So we are having, yes, total 5 numbers, and we will choose only 2. So 5p2 into 3p1. So what will be the answer? It will be 5 into 4 and into 3. So this will be same, right? So directly I'm using 5p2. Guys, don't like get confused. 5p2 means 5 factorial divided by 5 minus 2, 3 factorial, right? And you will open this 5 factorial till 5 into 4 because 3 factorial will be cancelled out. So directly I'm writing this one, this part. So that is equal to 5p2. So what is the final answer? It is 60. Yes. So 6.3, you are solving every question by two different ways. So now let us try another one. So now question number 4, find the number of 4-digit numbers that can be formed using the digits 1, 2, 3, 4, 5 if no digit is repeated, repetition is not allowed, and how many these will be even. Yes. So find the number of 4-digit numbers. So again, if we solve this question by previous method, so these are the 4 places, right? So this is your unit digit, this is the tens digit, this is the hundreds digit, and this will be the thousands place, right? So we have to find 4-digit number that can be formed using the digits, this one. So this is very easy because numbers are what? Numbers are non-zero numbers, right? Only condition is they are non-repeating, right? So we can start from either ways, like from thousand place or units place. So what will be the answer? It will be 5 into this thousand place can be filled by any of the 5 digits. So then 4, then 3, then 2, right? So answer will be what? Answer will be 120, right? And if we use that method to solve this question, so that is the second way to solve this question. So what we will do, they are talking about what? Okay, so first of all, we can try this one first part. How many 4-digit numbers? So out of 5, what we are doing? Out of 5, we are taking 4 digits. So 5p4. So 5 factorial divided by 5 minus 4. So it is 1 factorial, right? So this will be what? Same 5 factorial, and 5 factorial is what? 5 into 4 into 3 into 2 into 1, and that is again 120. Right? Now second part is what? How many of these will be even? Right? So if we talk about second part, so how many of these will be even? So even number, how we find the given number is even if its unit digit is even. So out of 1, 2, 3, 4, 5, even numbers are what? 2 and 4, right? So this unit place can be filled by what? We are having two numbers and we will choose any one number. So it will be done by 2p1 ways, right? And if we talk about rest of the numbers, so we are having 3, right? So 3 places are left, and how many numbers are left? 4. So 4p3. So 4p3 into 2p1. So that is equal to what? 4 into 3 into 2. So that is 4p3, and 2p1 means 2 only. So how many numbers? It is 48. So there are 48 even numbers out of these 120 numbers, right? If we make 4-digit numbers using 1, 2, 3, 4, 5, so total numbers are 120, and out of 120, 48 will be even. If you want to find odd numbers, so just subtract 120, and this 48 means subtract 48 from 120, you will get required number of odd, right? So these will be odd numbers. So let us move to next question. Yes. So now from a committee of 8 persons, in how many ways can we choose a chairman and a vice chairman, assuming one person cannot hold more than one position, right? If we read this question carefully, so here what we have to do, yes, here we are choosing two different persons, right? One person cannot be chairman and vice chairman, right? So simply this is what? This is 8p2. So this will be what? 8 into 7, 56, right? And by using that previous one, and that we were using that places, otherwise that is called box method, right guys? So suppose this is chairman and this is vice chairman. We have two positions. So this position, chairman position, so that can be filled by any of the 8 persons, right? So one person is chairman. So now that person cannot be a vice chairman. So now for vice chairman, 7 options are there, and by that rule of multiplication, principle of multiplication, so it will be 8 into 7, 56, right? So in this way you can solve question number 5. Next one, so find n if this is what? This is n minus 1 p3 and is 2 means, yes, this is n p4 and this is equal to 1 upon 9. So this is given, right? So tell me NPR. So that is what? How we solve NPR? So that is n factorial. So if we talk about this one, so this is n minus 1 factorial divided by n minus, so in place of n, we are having n minus 1. So n minus r, right? Achha, guys, if someone is confusing from this one, so just write NPR here. So here n is what? N minus 1 and r is 3, right? So then you will not be confused because this is what? N factorial divided by n minus r factorial. So here n minus 1 into n minus 1 whole factorial divided by n minus 1 minus 3 factorial, right? And if we talk about this one, so directly I'm writing this, or no problem, we can write in this way, n factorial divided by n minus 4 factorial, right? And this is equal to 1 upon 9, right? So this is what? N minus 4 factorial. And this is n minus 1 factorial. So in next step, what we will do? N minus 1 factorial divided by n minus 4 factorial into. So division is, we are replacing division with multiplication. So we will take its reciprocal. So n minus 4 factorial divided by n factorial. So guys, n factorial can be written as n into n minus 1 factorial, right? So if we simplify, so this one is gone, this one is gone, and we are left with what? 1 upon n equal to 1 upon 9, right? 1 upon n equal to 1 upon 9. And if we find the value of n, it is what? It is 9, right? So in this way, you can easily solve question number 6. So now question number 7. Find R if 5PR is equal to 2 into 6PR minus 1, right? So we had already discussed what is NPR. So here n is 5. So directly I'm solving first part. So this will be what? This will be 5 factorial divided by 5 minus r factorial, right? And this will be equal to what? 2 times 6 factorial divided by, yes, 6 minus r plus 1 factorial, right? So this was what? Don't get confused. So this was 6 minus r minus 1. right? So 6 minus r plus 1. So I have written this one. So now if we solve this further, so 5 factorial divided by 5 minus r factorial, and this is equal to 2 into 6 factorial means 6 into 5 factorial, and this will be 6 plus 1 7, so 7 minus r factorial, and we can write it as 7 minus r, then minus 1, so this will be 6 minus r, and here it will be 5 minus r factorial, right? So if we cancel these common terms, so we are left with what? On left hand side, we are having only 1. So 1 is equal to, yes, 2 6 are 12, right? Divided by 7 6 are 42 minus 6r, right? Minus 7r and plus r square, right? So finally we are having r square minus 13r, right? Plus 42 minus minus 12. So this will be plus 30. And if we factorize this one, so this will be what? Minus 10r minus 3r. So directly I'm writing r equal to 3 and 10, right? But the most important part we have discussed in case of NPR, what is the condition for r? R is what? R can be 0 and the maximum value of r will be n, right? So you can see here n is what? 5. So what is the condition for this r? R will be what? Less than or equal to 5. So 3 will be accepted, but we will reject 10. So answer will be 3, right? So let us solve second part. So second part is same almost, only the difference is here on right hand side it is multiplied by 2. So here you can see if we solve this one, so on left hand side we are left with 1, and on right hand side if I'm not multiplying this with 2, so we are left with what? We are left with 6 divided by, yes, here it was r square minus 7 6 13 r plus 42, right? Or you can write it as r square minus 13r plus 42 minus minus 6, it will be 36, right? So you can break this minus 13 as minus 4 minus 9. So finally you will get r equal to 4 and 9. But again, due to this constraint, r cannot be more than 5. So 4 is accepted, but 9 is rejected. So for second part, the value of r is 4, and for first part, it was 3. So in this way, you can solve question number 7. I hope everybody is clear, right? If still you will find any type of difficulty, you can share your query in the comment section, right? I'm waiting for your comments. So now question number 8. How many words with or without meaning can be formed using all the letters of the word equation? Using each letter exactly once, right? So how we solve these types of questions, we had already discussed. First of all, we will check, is there any letter which is repeating? So if we see this word equation, so all letters are distinct. So, and how many letters are there? 1, 2, 3, 4, 5, 6, 7, 8. 8 letters are there, right? And what we have to find, how many words with or without meaning can be formed using all letters. It means we are using all 8, right? So it will be what? 8p8. If you read the question carefully, so in fraction of seconds, you can solve the question, right? So 8p8 will be what? It will be 8 factorial divided by 8 minus 8 factorial. And we had already discussed, always remember 0 factorial is equal to 1, and that is equal to 1 factorial. So don't write it cannot be determined, right? So this will be what? 8 factorial only. And 8 factorial, how we had solved this in 6.1 exercise, not in 1, it was in 6.2. So 8 into 7 into 6 and so on up to 1. So I'm writing the final answer. It is 40320, means 40,320. So that will be the answer for question number 8. So now let us solve question number 9. So here what we have to find, how many words with or without meaning can be made from the letters of the word Monday, just like previous question. Assuming that no letter is repeated. So what is the first part? 4 letters are used at a time. In previous question, all letters we were using. So here 4. So it means total are how many? 1, 2, 3, 4, 5, 6, and no letter is repeating. So answer will be what? 6p4. Right? So it will be 6 into 5 into 4 into 3. So what is the final answer? 360. Right? Question number 9. Yes, 360 is the correct answer. And what is the second part? All letters are used. So it means just like previous one. 6p4. Sorry, 6p6. All letters are used. So this is what? 6 factorial. Right? So already we have used this 6, 5, 4, 3. So we will just multiply this with 2. So 360 into 2. So that will be 720. So 720 is the answer for second. So third is all letters are used, but first letter is a vowel. So now there is a condition, right? First letter must be even. So let us check how many even numbers, vowels are there. So we have 0, O and A. So we have 2 vowels, right? So first place can be filled by 2p1 ways. And next, how many letters are left? Out of 6, 5 are left. So 5p5. So this will be what? 2 factorial into 5 factorial. Right? So what is the final answer? Yes, guys, it will be 240. Right? I hope everybody is clear. So question number 9. Now moving to question number 10. So in how many of the distinct permutations of the letters in Mississippi do the 4 I's not come together? 4 I's, right? So this is the second type. We had already discussed, if in a word letters are non-repeating. So how to make total arrangements? So this is simply we just count the letters and we write its factorial. Number of letters, that factorial, right? So here, first of all, if we see this one, so many letters are what? Repeating. So let us check M. M is only one time. If we talk about I, so I is 1, 2, 3, 4. 4 times. And then S, 1, 2, 3, 4. 4 times. And if we talk about P, it is 2 times. Right? So is there any letter which is left? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Total 11, and we have written all. Right? So here they are talking about 4 I's not come together. Right? So look at the case. 4 I's not coming together plus 4 I's coming together is equal to total number of permutations. Right? So what we will do, first of all, we will find total. So total number of words with or without meaning we can make with the help of Mississippi, how many letters are there? 11. So 11 factorial, right? And I is repeating 4 times. So that will be 4 factorial, right? S is repeating 4 times. So that will be 4 factorial. And P is repeating 2 times. So this will be 2 factorial, right? So in this way, so this will be the total. Suppose this condition is not given, 4 i's not come together. And simply like we have to find the total number of possible words with the help of this, right? So this will be the then minus, if we write all i's are together, right? So look at this one. How many i's are there? 4 i's are there. It means remaining 7 letters are there. So 7 plus 4, 11. So now what we will do, we will make these 4 i's as one unit, right? So total we are having 7 plus 1, this unit, we will consider this as one unit, complete 4. So this will be what? 8, right? So total 8 letters, and 8 letters can be arranged in this way, 8 factorial, and out of these 8, S is repeating 4 times, so 4 factorial into 2 factorial, right? And here, like we will solve next question, so you will come to know this I. So here i's are same if they are different. So further we will arrange these 4 i's, right? So this will be what? 11 factorial divided by 4 factorial into 4 factorial into 2 factorial minus 8 factorial divided by 4 factorial into 2 factorial. So what is the final answer, guys? This will be, just solve this one. I'm just writing the final calculation, 34,650 minus 840, right? And what is the final answer? It is 33,810. So this will be the final answer, right? So let us move to next question. So here, in how many ways can the letters of the word permutations be arranged if the words start with P and end with S, right? So it means they are fixing the position of P and S, and in between there will be different letters, right? So position of P and S are fixed, and it is clearly mentioned it will start with P and end with S. We cannot interchange P and S, right? So check how many letters are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So total 12 letters are there. And is there any letter which is repeating? Yes. T is repeating 2 times, right? So 2 are already arranged, P and S, they are fixed. So we are left with how many letters? 10. So they will be arranged in 10 factorial ways, right? But 2 T's are common. So answer will be 10 factorial divided by 2 factorial, right? So this will be the first part, and I'm directly writing this answer. So this will be what? 10 factorial divided by 2 factorial. Answer will be 14400. So this will be your final answer, right? I hope this is clear to everyone. This will be like 18 lakh 14,400. So now next one is what? Vowels are all together, right? So permutation is a special type of word. Here you are having all 5 vowels, right? So if we talk about vowels, so 5 vowels are there. So it means remaining are consonants. So total were 12. So 7 will be consonants. So all vowels are together, right? So that is the condition. So what we will do, we will make these 5 vowels as one unit, just like previous question. So total will be how many? 7 and 1 unit of vowels. So it will be 8. And in how many ways they will be arranged? 8 factorial, right? But two t's are same. So it will be what? 8 factorial divided by 2 factorial. Now, if we talk about these 5 vowels, so all 5 vowels were distinct, right? So they can be further arranged in 5 factorial ways. So what is the final answer? 8 factorial divided by 2 factorial into 5 factorial. So I'm writing the final answer. You guys will calculate this one. So this will be the very big answer, right? Again, we have like 24,19,200. So this is the second part, right? So now coming to third part, there are always 4 letters between P and S, right? So now again, position of P and S will be fixed, but this time in between there are number of letters are fixed. So P and S. So in between there will be 4 letters. So suppose we will start P's position at first. So this 1, 2, 3, 4, 5, 6. S will be at 6. If we like change the position of P to 2. So this will be 7, right? 3, this will be 8. Then total we are having how many letters? 12. So there will be 12 positions, 6, 7, 8, 9, 10, 11, 12. Right? Similarly, here we will have 1, 2, 3, 4, 5, 6, 7. So total, how many possibilities are there to arrange P and S so that there will be only 4 letters? So we are having 7 possibilities. And this time, P and S can also interchange. We can also interchange these two P and S. So they are interchangeable. So now two, they can be arranged in 2 different ways. They can change the position, and we are having how many different options to arrange P and S such that there will be 2 positions, 7. So 2 into 7. And now, yes guys, if 2 letters are arranged, so now we are left with what? 10 letters, remaining 10, and they will be arranged in 10 factorial ways, and 2 t's are same. So this will be what? 2 into 7 into 10 factorial divided by 2 factorial. So what is the final answer? I'm writing the final answer. It is 10 factorial divided by 2 factorial, 2 into 7. So 14 into 10 factorial divided by 2 factorial. The final answer will be what? I'm writing the final answer. This will be a very big number this time. 2 crore 54 lakh, right? 16,000, 1600, sorry, right? So this will be the final answer, right? So in this way, you can solve question number 3. So this is all about your exercise 6.3, right? So if you like this lesson, so please share this with your friends. And in case of any doubt, you can write your doubt in comment section, and subscribe this channel for more educational videos. So bye bye guys.